Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between mean, median. Definition: the the sum of all values divided by the total number of values is called mean. The middle value in the data set when all values are sorted in ascending or descending order is called median. Calculation: mean is calculated mu equal to n1 summation I equal to 1 n xi. Median, the value at the n1 plus 1 divided by 2 position for odd n, or average of n2 n divided by 2 and n2 plus 1 position for even number. Sensitivity to outlier: mean is highly sensitive to outlier and extreme values. It is easily pulled towards the tail. Median is robust to outlier at extreme values. A single extreme value does not affect the middle position. Data requirement: mean, average, mean require interval or ratio level data, quantitative data. Median can be calculated for ordinal, interval or ratio level data. Central tendency: mean represent the center of gravity of the distribution. Median represent the 50th percentile. 50% of data is above and 50% is below. Distribution shape: mean is in a symmetric normal distribution, the mean equal to median. Median is in skewed distribution, the median is better measure of central tendency than the mean. Statistical properties: mean, the minimizer of the mean square error MSE. Median, the minimizer of mean absolute error MAE. Example: mean reporting the average income often pull up by few high earners. Median, reporting the median income, a truer picture of the typical person income. Moving to question: difference between regularization and normalization or standardization. Primary goal in regularization, to prevent overfitting by penalizing large model complexity weights. In normalization, to rescale input feature to standard range or distribution to avoid model training. Application stage: regularization applied during the model training process, added to the loss function. Normalization applied during the data pre-processing phase before feeding data to the model. Target of change: regularization modify the objective function and the resulting model weights. Normalization modify the input feature values themselves. Handling of overfitting: regularization reduce variance in model, making it more generalized to unseen data. Normalization does not prevent overfitting directly but improves the training stability and speed of the optimization process. Scale dependency: essential when features are not scaled, as unscaled feature can dominate the penalty. Normalization independent and regularization, but greatly benefits regularization by putting all feature on equal footing. Techniques: regularization L1 lasso, L2 ridge, dropout, early stopping, often considered a form of time regularization. Normalization min-max scaling, normalization Z-score scaling, standardization. Impact on weights: shrinks model weights towards zero. Normalization, no direct impact on the final model weight, but affect magnitude of the initial initial gradient steps. Core principle: based on the principle of ocean razor, simplest model is best. Normalization, based on the principle of improving convergence in iterative optimization algorithm.